at many places you have to check your network with varying some parameter. Okay, like suppose number of nodes you want to change. Okay, or you want to change the data rate, or you want to change something else. Suppose for a very simple thing, I will tell you. Suppose we want to change the number of packets present in the queue. Okay, so this is 50. Now, if we run this file, what will happen? If we run this file wlab1.tcl, one trace file will be generated. Okay, this is the file which I will run. So corresponding trace file will be generated. Now what will happen? We will get the result of it using wireless.awk file and .trace file. Okay, whatever result we want. But when we run this program again by changing this value to suppose 40, then what will happen? And if we run it, then what will happen? This file will be rewritten. Okay, so the previous content of this file will be gone. Okay, so we won't be able to see the output of previous simulation. Okay, only the output of current simulation we will be able to see. So for this purpose, these things may look very small, but when you simulate your network, you will have to run the simulation hundreds of times. So in place of replacing the old file, you will have to save the old file and make a new file for every simulation. For that purpose, what you can do, either you can copy, suppose I have run it, I will copy this file into some other folder with a different name, and again I will rerun it, then will save it in with a different name. But it will take a lot of time and will be very irritating. So what is the shortcut to do it? You have put suppose IFQ length 5 first. Okay, IFQ means it is the length of the queue. Now here I have written the file name as wireless_out.tr. What I can do, I will change its name to $value of IFQ. What is this? Value of IFQ is what? It is this thing. Value of IFQ. The value of the length of the queue. Okay. So what will happen now? When I run this program, the value of the simulation will be stored in a file, means all the events of the simulation will be stored in a file named wireless_out_5.tr. Okay, so let us run it and let's see it happens or not. Okay, so now wait a minute, I think I have not saved it. Okay, I have not saved this file. I have saved it now and I will rerun it. So let us see. You can see here, if you are able to see, wireless_out_5.tr, this trace file is created. Okay, now if I want to change this value to 10, now what will happen? If we rerun this program by changing just the value of the length of the queue, if we run it, the old file will not be replaced. Okay, what happened now? Another file is created named wireless_out_10. Okay, now if you change this value to 15 or anything, then what will happen? Again a new file will be created. So every time you run the simulation, your value is your old file will be saved and a new file will be created for every simulation. Again now wireless underscore out underscore 15.tr is created. Okay, so what will happen? It will save a lot of time of you. Means if you rerun the simulation again and again by replacing old files, suppose now you want to check the result of the previous file, what you will have to do? You will have to rerun the simulation, but using this technique you have stored all the trace files. Okay, these things may look very small, very easy, but these things are very important. You should know these things, small things, so that you don't waste your time in ordinary things. Okay, so now what you will have to do, just press the command awk-f. awk file name will be same and wireless out underscore, you can get the value 5.tr. This value you have got. Now 10.tr if you directly write here, the next value you will get. Okay, if you write 15, again the next value you will get. So it will be very fast for you. Okay, so this process becomes very fast. Okay, so these are two simple tricks that you can use and it will help you in the simulation and make your simulation fast. Okay, now I think you all understand this. It is very simple. So always write your trace file name with relation to the variable that you want on the x-axis. Okay, so that it will be very easy for you. Okay, anybody has any doubt?
Sir, जो average energy is there, that is including the cluster head also, energy of the cluster head also.
Which one? Wait a minute, let me see.
Sir, in the previous trace file.
Okay, the output.
Yes, sir, output.
Yes, actually currently we have not made any cluster head, means we are not doing any clustering. Okay,
Yes, sir.
but when you do clustering, even then it will be including the cluster head as well. Okay,
Okay, sir.
but if you want to exclude, you can exclude it. Okay, but that will be a different thing, means in trace file you will have to change using the code. Okay, but in general it will be including the cluster head as well.
Right, sir. Right. Thank you.
Okay. In some cases, as sir has said, I think some of you might have faced this problem. In some of the scenarios, the cluster heads have a large amount of energy. Okay, I have seen these things. So, in that case, we want to calculate the energy of the nodes other than cluster head. Okay, so for that purpose, what you can do, you can get the energy consumption. Okay, and the energy of cluster head you can calculate separately. How you can calculate energy of the cluster head separately? By printing in your in your source code. Anywhere you print the energy, like I told you. Okay, energy I have not told you. So okay, I will tell you now. Suppose you want to get the energy of this node as well. So what you can do? Now this line I will comment because we have already printed it. So printf, if you want to get the energy of something from your source code, so just print %f, I will write something extra, energy of node is from. Okay, for getting the energy, you will have to write the variable that is containing the node, then energy model, it is somewhat different, energy model and energy. Okay, this thing you will have to write. Okay, so we have rebuilt it and let us run it again. It might be using some sleep function. Go to sleep like this, set no sleep. Many things are there. Okay, so the source codes are written in such a way that you can get some idea with the name of the file and name of the variables itself. Okay, and whenever you design a new code, new source code, means suppose you have written a code for your protocol, then you should make it public if you want, and always define variable which have a name that represents its work. Okay, you don't write the name A, B, C, A1, B1, C1 like this, don't write. Otherwise, nobody can use your code. Okay, suppose here in energy model dot and call that function from here. Okay, that will be the good idea. Okay. Yes, sir. You can create your function whatever you want. You will have to